Everyone, welcome back to another episode of Unscripted Coding. Today, we are going to do another LeetCode problem. LeetCode, of course, is an online repository of programming algorithmic challenges. And what I found is actually, you guys are watching the easy problems more than the hard ones. So today, I'm going to do an easy problem just at random, and we're going to walk through it in real time. So let's just pick one at random. And we have 1103, distribute candies to people. Let me just zoom in so you guys can see pretty clearly. We distribute some number of candies to a row of n number of people in the following way. We give one candy to a first person, two candies to a second person, and so on until we give n candies to the last person. Then we go back to the start of the row, giving n plus 1 candies to a first person, n plus 2 candies to a second person, and so on until we give 2 times n candies to the last person. This process repeats with us giving one more candy each time and moving to the start of the row until we reach the end. Until we run out of candies. The last person will receive all of our remaining candies, not necessarily one more than the previous gift. Return an array of length number of people and sum of candies that represents the final distribution of candies. Okay, so this is pretty simple. This is a very classic type of loop. And as usual, I'm going to do this in Python, but let me just, I probably should have set this up beforehand. Clear up the screen here. Okay, so the idea is you have a number of people. Let's have 1, 2, 3 people. Okay, each of those are a head. And then the idea is you get 1 candy, 2 candy, 3 candies, 4 candies, 5 candies, 6 candies, 7, 8, 9, 10, and then whatever is remaining. So let's say there's 3 candies remaining. And I think the output is you're just going to add all of these together. So this is 22. This would be 18. And this would be 18. Very, very simple. So there's probably a really clever way to solve this by, eventually just reducing what these numbers are and then having some formula for n. But my initial thought is let's do it the way that you would write it out, exactly the way we would write it out. So we start with 1, 2, 3, and just loop through adding to it. So what I would do is create an array here, start it off at 0, 0, 0, 1 for each person, and then just add the numbers to it. So this becomes 1, this becomes 2, this becomes 3, then what's the next number? So this 1 plus 4 would be 5, and then 2 plus 5 is 7, and basically slowly adding onto it, keeping those same 3 numbers only. Hopefully that's intuitive and that makes sense, but let's start writing out the code. Okay. So what do we get? We get number of candies int of people. Zoom out a little bit. And I just like putting things into Code Sculptor. It's what I'm comfortable with because I can run the numbers myself. But the problem is you have to initiate the solution class. Oops. You gotta initiate the solution class and run the problem. So we will say Candies, let's say 102 candies, and num people will say 4, okay? And then we'll say solution.distribute candies, and then we have candy num. No. What I'm going to do is print it out first, make sure that this last segment is actually working. Good. So we return something, and it is correct. So the other thing, let's just make sure we get the right people. So num people 102 and 4. Okay. I normally start with what the type of my output is, and this time it's going to be an array. We want to return this type of an array. That is the size of num people. Now, Code Sculptor has these lovely docs that help out, and I have always been really terrible at how to initiate. So, initiate list Python thing. I know there is a function here. Okay, I guess not. Okay, so what we're going to do is have a list. What we want to do is initialize a list of num people. So it's length num people. We say there are 4 people, so it should be 4. We multiply it by num people, the 0 list, and what should return is a list of 4 zeros. Perfect. Okay, now, next thing we're going to do is start adding the candies. Count. We will start at 1. 4, n in range. And what we're going to do is loop through each candy. So for each candy, okay. Remaining candy equals candy. What we're going to do is slowly subtract from the pile. So for example, we have 102 candies to begin with. We hand out 2, we subtract 2, obviously. But as it goes further, the easiest way is just to slowly subtract out the candies. And the best part is, we can do a check here. And I'm just going to leave a comment here. Check if remaining candies is larger than count. Okay. count plus. What we want to do is find out which person we are dealing with. So 0, 1, 2, and 3. What person index, let's call it, because the array is indexed 0, 1, 2, and 3. We got to figure out for the nth candy, it is allocated to person 0, 1, 2, or 3. And I think the easiest way to do that is to use the modulo function, which is kind of the percent sign. If we candies divided by modulo number of people, known people. What modulo is the remainder. So for example, if I go, if I do a division, and candies divided by number of people would be 102. 102 divided by 4. Modulo is the remainder of that division. So we would say 25 remainder 2. Modulo gives you the 2, the remainder of that number. What you have to do is subtract by 1 to get the right index, because if you think about it, 1, if you have the first candy, you're at 1. Your modulo divided by 4, your remainder is, so 1 divided by 4 is 0, remainder 1. So it's giving you 1. But what you want to target is person 0, because arrays are indexed by 0. You got to subtract 1 to get to it. Now, I am going to very quickly check that we are doing this right. Uh-oh. Nope. Candies modulo. Not candies. N. Here we go. Oh, I think I was wrong. You don't need to divide or subtract by 1. You get 0, 1, 2, 3, 0, 1, 2, 3. Yes. Okay. The range starts at 0 all the way to 101 rather than 1 to 102. So ignore what I was saying before. Perfect. So we know to give it to. Now we're going to say output person index equals, and we're going to add the current count. Okay, and then after we add it, we increment the count. So equals count plus 1. Increment count. Find index. And add number 2 already. Now, the problem we have is we're giving way too many candies. By the time we hit 102, we're not giving out 102. We ran out of candies. So what we have to figure out, what we have to do is subtract those candies out as well. Increment count, clean numbers. So we have given away the count, so we're going to subtract remaining candies. Line equals remaining candies minus count. And before we add the number, we should check that remaining candies is greater than 0. that's the first check. Let's do this first. The second check that I left a comment on earlier is it has to be larger than count. So let's say we get to the very end. We're supposed to give the person 40 candies, but we only have 10 left. We're not going to add 40. We're going to add the last 10. That's according to rules. The last person will receive all of our remaining candies, not necessarily one more than the previous gift. So we got to figure out if remaining candies is less than the count, then we're going to do this plus remaining candies. And then, of course, we clean it up with an else. We'll run it right here. Okay, let's say 101. And you can see, seems like this is the last person to receive candies. Okay, let's see if they will accept our answer. And if they do, then I can go back and explain it. I should increase the screen size here. We can clean this up. Oh, time limit exceeded. What happened? Okay, so we passed 26 out of 27, but one of them didn't. Last executed input. The input is 1 billion candies over 1,000 people. So let's put that in. 1, 2, 3 over how many people? 1,000. Oh, okay. Uh-oh. What have we done? I have frozen my computer. Obviously, we have done something we shouldn't have. So, I am thinking there is a much quicker way to escape this. Because it's going to keep running. It's going to keep running even though it's well past that number. So what I'm saying is, even after we hit remaining candies is 0 or, runs out, we should be breaking out of that loop here in that else statement at the very bottom that you can barely see. So, okay, so I'm going to edit the code here. Edit code sculptor. And just break. And let's take a look. Python break loop. Oops. I broke it in the wrong place. If remaining candies is greater than 0, good. If not, I think this is the best place to break it. Alternatively, I can break it here. Nope. Break, okay. Here we go, yeah. So what happens is as soon as remaining candies is less than 0, so we ran out of candies or is equal to 0, we're going to stop the loop. Now, the one we were stuck at, there were a billion candies, and we didn't take the time to break the loop. What that meant is that we just kept running. After we ran out of candy, we still went through the next person, 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 and so on. So it's very, very difficult. It's just so many checks and so many things to run. Okay, let's just run through this problem one more time so that we can understand what we did with the code. First of all, we decided to shape the output. What we did is create a list or an array that's size of number of people. So if there are 4 people, it's 0, 0, 0, 0. If there's 1,000 people, it's a list 1,000 long. Each entry in that list represents a person. We set the remaining candies equal to candies, and what we're going to do is slowly subtract out of it so that we hit 0 at a certain point. We start off count at 1 because the first person is going to get 1 candy, and then we're going to slowly increment so that the next person gets 2, then 3, then 4, then 5, and so on. Then we start iterating. For each candy, we just go through the loop. There's probably a better way of doing this. You can probably think of the number of loops that has to happen to make this work, but we're going to break out of it, so why worry about this? Next, we decide to figure out which person we're handing out the candy to. Is it person 0, 1, 2, or 3? We use this candy modulo feature, and so that gives you the remainder in a standard division type of operation. So with person index, you'll get person index 0, 1, 2, or 3. This is super handy. If you don't understand it, do check it out. Modulo function is how you spell it. It's very useful. Now we're going to do our increments, but we're going to do a number of checks first. We got to make sure that there are still remaining candies, so remaining candies have to be greater than 0. If it is less than what the current count is, so I need to hand out 45, but I don't have enough remaining candies, I'm just going to give out what's left over. But if I do have enough, I'm just going to give what the count is. So I have 1,000 candies, I got to give 45 out, I give 45 out. And then if there are no more remaining candies, I break out of the loop. So I stop this entirely, we're done, we return the output. After we do this loop, after we do this check, we gotta clean up the numbers. So remaining candies, we subtract out what we've given out, and then we increase the count so that it becomes the next count. Can probably delete this. And then finally, we return that output array to make it nice and clean. So there you have it. It's a super simple loop, but we used a number of really handy features. A for loop, an array, we used modulo, and of course we incremented and decreased a number. I hope you found that helpful. These easy problems are really hard when you start off with, but then they start to follow the same patterns over and over. I can tell you now, I have seen this exact problem in my homework before. Not framed in the whole candies to different people, but there's only so many ways you can teach these loops. So you want to get the basics down. If you enjoyed this video, thumbs up, leave a comment. If not, if you want to see me tackle some harder problems or cooler projects, do leave me a comment below as well. So thanks for watching. See you guys next time.